In this lesson, we'll be working with distributive property, and we are going to use it to evaluate expressions and use distributive property to simplify expressions. So your first vocabulary is distributive property. And if you will look, it's for any numbers A, B, and C. I have A outside times the sum of B plus C. And what that will simplify to is A times B plus A times C. As you can see here, I am distributing or handing out this A out front, multiplying it by everything inside. If you think about this classroom, if somebody were to come in and distribute something to all of you, you would expect every single one of you to get something. It's not fair to leave anyone out. Same thing with distributive property. This A has to be multiplied by the B, as you see here, and then multiplied by the C, as you see here. And distributive property can go both ways. I can start here and multiply, or I could start here in what we call factor. We'll be working with both this year. So here's an example of how we would use distributive property. It says rewrite 7 times 49 using distributive property and then evaluate. Well, what's 49 really close to? 50. So we're going to take 7 times 50 minus 1. See if you can make that make sense in your mind. I have 50 minus 1, which is 49. So now I'm going to use distributive property to solve this. And it's a way that you can use maybe mental math. So 7 times 50, you know that's 350, and you can use your calculator if you want to check my work, minus 7 times 1, which is 7. And when you subtract, you get 343. So we were able to just mentally solve something, 7 times 49, which would take maybe a calculator to solve. So using distributive property is a good way to show mental math. We can also simplify expressions. This is to rewrite each expression using distributive property and then simplify. So when I take the 7 times the 3W, think of this as 3 walruses. I have 7 groups of 3 walruses. So that's going to be 21 walruses. Minus 7 times 5, which is 35. Now, can I put these together? The answer is no. These are walruses, these are bananas, totally different. They're not the same thing. So I cannot put them together. So this is what we would call simplified, and we're done. In this example, do you see how the 4 is at the end? I do not like how the book does this. If I have a 4, it should be out front. I'm actually going to rewrite it to show you how this should look. And the reason I do this is so this is clearly something that is multiplied. This to me looks like a power. So you'll see some examples like this. I would like you to rewrite it so that it really looks like distributive property. 4 times 6v squared would be 24v squared. 4 times v, and see this is a plus, so it's 4v, minus 4 times 3. And if you look here, these are v squareds, these are v's, this is something else, so this is completely simplified. We'll talk more about that in a second. So you can work an example on your own here in just a moment. Like terms are terms that contain the same variables with corresponding variables having the same exponent. So in order to be like terms, it's got to be same variable, same letter, and same exponent, same power. So for example, in that last example, we had 6v squared plus 4v, something like that. These are different powers, same letter, v, but different powers. So these are not like terms. That's why I can't put them together. Simplest form is an expression in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. So this is in simplest form because there are no like terms, no parentheses involved. This right here has parentheses. This is not simplified. I would have to use distributive property and get 4x plus 4 times 2, which is 8. This is now simplified because I cannot put anything together, no like terms. Coefficient is the numerical factor of a term. Another way to say it is the number in front of an expression, number in front. So the coefficient here is 6. The coefficient here is 4. I'll show you a couple more examples in a moment. All right, so like terms here, if you look, what can I combine? I can combine the a squares because they're the same letter, same power. So I have 6 plus 2, which is 8, a squareds. Now this 2a cannot be combined because it is a different power. Same letter, but different power. So this is actually simplified. Let's see if we can simplify this. 17u plus 25u. Well, if you look, they're all the same letter, same power. So yes, we can simplify those. I have 42u, and you can double check my addition there with your calculator if you want. Here I have 6t squared plus 3t minus t. If you look, this is a different power than these two. These are both t to the 1, just t. So I can put them together. So 3t minus t, 3 tacos minus a taco would be 2 tacos, right? So I have 6t squared plus 2t. I cannot put these together. Different power. Same letter, but different power. So this is what we would consider to be simplified. Okay? You can work another example in a moment here. Coefficient is the number in front, so in this case your coefficient is 6. In this case, if it's x squared divided by 3, another way to write that would be this. Let me pause a second. Do you understand? I'm taking x squared divided by 3, so it's really in 3 parts. So I have 1/3 of it. So your coefficient in this case is 1/3. And you can ask me about that tomorrow if you need to. And here, as you can see, I have a y. How many y's do I have? 1, right? And there's not a number in front. In algebra, we don't say 1 when we have 1. And here's my example. Do you see how I have 1 pen? Do I say, hey, look at my 1 pen, guys. See, I have 1 pen. This is my 1 black pen. No, that sounds weird. I say, look, I have a pen. This is my pen. I'm going to use my pen. And I have 1 y. So my coefficient here is 1. So you'll do some examples on your paper. We're done.